Hi, my name is Muhammad YUNUS bin Hamidin and my metric number is 2510433735. Today I will walk through the full flow of a Castep assignment from setting up a crystal structure under high pressure to calculating its electronic band structure. We'll be using the Cambridge Sequential Total Energy Package or Castep running on Ubuntu environment. Firstly, I open Ubuntu terminal and copy-paste directory command. I analyze our working directory using the command line. I create a new folder and I will name mine geometry to ensure can move files between Ubuntu and Windows without restriction. After that, I download off the bahan cell template and compound data of mine. I am downloading a standard cell file and the specific crystal data for our compound, BAZRO3. Once downloaded, I will rename it to bazro3.cell to keep our project organized. After I open Notepad and copy the lattice parameters and representative sites, crystal information is stored in the bazrs.cell file. I am copying the lattice parameters, the ABC value into the block lattice ABC sections. Then I will paste the atomic coordinates into the percent block position frac section. This tells Castep exactly where each atom sits in the 3D grids. After that, I highlight the pressure block in the cell file. A key part of this assignment is studying material under stress. We must define the external pressure. I am navigating to the percent block external pressure section. By default, it is 0. I will update this to 400,000 atmosphere as required for this simulation. For task 1, geometry optimizations, I open the BAZRO3 parent file and change the task, while the zro3.cell file defines that what the parent file. The screen text, which is geometry optimization. Return to Ubuntu and run the mpi command.
One eternity later.
We need to perform a geometry optimization. This tells the software to shift the atoms slightly until they find the position with the lowest total energy under our specific pressure. I will run a grep command to search for the success message in the .castep file, saying geometry optimization complete successful means our model is physically stable. Reviewing optimized constant, this is a BFGS final configuration table. Under 400,000 atmosphere, our lattice constant has shrunk. We will use this new optimized dimension for our next step, which is the band structure. For our task 2, band structure calculation, change test to band structure and add the k point underscore path. Now, I update our parameters. I change the task to band structure. We also add %block BSK point path into the cell file, which define the direction in the crystal we want to probe for electronic energy levels. If our file's ready, I trigger the calculation. We use Castep.mpi followed by our compound name. This process uses complex equation to estimate electron energy maps for each atoms on tab, which is Castep.mpi BAZRO3.
Right here, I have a problem which is a bad file descriptor. So let's look at how I figure out. After I figured out the problem, I finally found the solution.
A few moments later.
After running the band structure task, I use the depression command to generate a graph. Analyzing optimization results. Use a graph to check the output file simulation time varies. So we must verify the result. This visualization shows us the energy gap, the space between the valence and conduction bands, which determines our material is an insulator, semiconductor, or metal. By following this step, we have taken a raw crystal template subjected to extreme pressure, allow its atoms to find their natural equilibrium, and final map its electronic behavior. This workflow is a cornerstone of modern material research. Thank you for following along.